Okay, office hours for the first pretest assignment 9, non-calculator section. On your test, you're going to have two sections, one for calculator, one for non-calculator. We're going to do the calculator one first, actually, and it time-wise won't be um, as intense. The non-calculator section, which this is based off, that one's gonna be a little more time crunch. So generally give you guys an extra 10 minutes beyond class time if you would like to take advantage of that. If your first period, you come 10 minutes early. If your second period, you work in a break. If your third period, you could start 10 minutes early, vice versa. Fourth period, 10 minutes into lunch. So no calculator for these exact values. Hopefully these are pretty quick problems, these first ones. I would say alpha is 30 degrees, quadrant 2. So sine of 30 degrees is 1/2 and quadrant 2 is positive. Done. Okay. Cotangent. Now with radians, I really challenge you to not convert them to degrees. It's going to take too much time. I just told you you're not going to have enough time. So you need to get good at this right now. So with radians, first of all, tangent is 1 over, or cotangent is 1 over tangent. So it's going to be cosine over sine. So I'd write that down because I'm not going to memorize tangent, cotangent, secant, cosecant values. Now, if it helps, you could start to draw pictures. 3 pi over 3 is half a circle, and then you have another 2 pi over 3. 6 pi over 3 would be 2 pi. So your reference angles right here is pi over 3. So alpha equals pi over 3. We're in quadrant 4, okay? Now, the angles in radians are 0, pi over 6, pi over 4, pi over 3, pi over 2, okay? The denominators get smaller, the angles get bigger. So pi over 3 is this further one. So that's for sine, that's 0, 1/2, root 2 over 2, root 3 over 2, and then 1. And then cosine's the same values but backwards, okay? So cosine is going to be 1/2, and we're in quadrant 4, so it's positive. And sine is going to be root 3 over 2, but we're in quadrant 4, so it's negative. So we get negative 1 over root 3, which is also negative root 3 over 3. Okay? Make sure you get the sign correct. That's a big part of the answer on these. Secant is 1 over cosine, 4 pi over 3. Now, 4 pi over 3 is here because this is 3 pi over 3 because that's pi, right? And then so the reference angle is pi over 3. And we just got done talking about that. That's going to be the bigger angle for cosine starts at 1, root 3 over 2, root 2 over 2, 1/2. We're in quadrant 3. So reference angle is pi over 3. We're in quadrant 3. Cosine is a negative. So the final answer is -2. I do want you to simplify these. Okay, next one, cosine of -510. So -360 would get you right here. And then that would be another 150 would put you at 510. So we're at -360. -150 puts you right here with a 30-degree reference angle. And so reference angle is 30 degrees. We're in quadrant 3. Okay, you got to go backwards because of the negative angle, right? To get to there. So cosine of 30 degrees, that's a smaller angle. 1 root 3 over 2, you're in quadrant 3, so it's negative. Done. Okay? All right, so there's those questions. We're going to have some solving trig equations, solving trig inequalities. There will be directions as to the domain of answers I'm looking for. And so here we go. Let's show the work. Sine x equals -1/2. Reference angle. When does sine equal +1/2? 30 degrees. When is it negative? Quadrant 3, quadrant 4. So x equals quadrant 3 be 180 plus alpha 210 plus 360k. And then x equals quadrant 4 is going to be 360 minus alpha 330 plus 360k. And then we just want the answers from 0 to 360. So 210 and 330. But this is the way I would show the work. I'm just trying. This is the way I would do it. I treat every trig problem the same. So I'm just ready to go for any of them. This one, we need to isolate the trig. We need to add root 3 to both sides, divide by 2. Reference angle is, when does cosine equal root 3 over 2? That first small angle, 30 degrees. Now, we are going ahead and dealing with degrees on these problems because that's the directions were stated. So these are all degrees. Okay. In fact, most of this test will be degrees. What quadrant are we in? When is cosine positive? Quadrant 1 and quadrant 4. So 2x equals, quadrant 1 is 30 degrees plus 360k. In quadrant 4 is 2x equals 330 plus 360k. And so we're going to divide by 2, divide by 2, divide by 2, divide by 2. So we're going to get x equals 15 plus 180k. And then x equals 165 plus 180k. And then I just want all the answers from 0 to 360. So you could just do this 15, 195. If you add another 180, you're going to be at 375, too much. 165 plus 180 is 345. They don't have to be in order, but whatever. So okay, this one, cotangent. Cotangent is 1 over tangent, right? So this is going to be tangent sine over cosine. So this is going to be cosine over sine, because I don't want to memorize any more values than I already have to. Now, you want to make this into a fraction. Now, you got to be like, well, those don't look like values I've memorized for sine and cosine. Well, put some 2's under. Oh, yeah, that looks better. So what's alpha? When does cosine equal root 3 over 2 and sine equal 1/2? Just think positive first. Well, that's 30 degrees. Okay, well, what quadrants is one positive and the other negative? Now, this negative doesn't necessarily belong to the top. It could be from the bottom. So what quadrants do they have opposite signs? Quadrant 2, sine's positive, cosine's negative. Quadrant 4, cosine's positive, sine's negative. So those are your two answers. Now, it's tangent and cotangent have a period of 180 degrees. So you could take advantage of that and say, okay, well, let's just find the first one here. 180 minus alpha is 150, and then just do plus 180k. And then you don't have to do any other, you don't have to do a second scenario. Otherwise, you got to do the second scenario. Okay? So, but this would be the quicker way. Just one scenario here. If you did the other, you would also do 2x equals 330 plus 360k is what you would do. You do this 360k, that 360k. But I'm saying you could just avoid that and say x equals 75 plus 90k. And then you just have one expression, and you want all the answers from 0 to 360. So 75, 165, 255, and 345. We do expect to get 4 answers. When you have that extra 2 inside, it's going to double the answers you usually get, right? Okay, so show your work, nice and neat, get these right. These are inequalities. So we're going to do the same work up front. We're going to solve for the roots, okay? But then we're going to do a line check afterwards. So when does sine equal 1/2? 30 degrees. When's it negative? Quadrant 3, quadrant 4. So 3x equals, quadrant 3 would be 180 plus alpha 210 plus 360k. And then quadrant 4 is going to be 330 plus 360k. Okay, divide by 3, divide by 3, divide by 3, divide by 3. X equals 70 degrees plus 120k. And x equals 110 degrees plus 120k. And so we get 70, 190, 260, 330, 110, 230, 350. Okay, let's see. Did I make a mistake anymore? I think I made a mistake. 190, I added 70. It's supposed to add 120, so this should be 310. Now, I knew I made a mistake because I thought, well, I should get 6 answers, and I had 7. So it didn't quite make sense. Now, we're going to do a line check. So let's put our boundaries on here, 0 to 360, and then these dots need to go in order. They're going to be open dots. Now, are any of these that bounce issue? Did you get sine or cosine equal plus or minus 1 when you isolated sine or cosine? Nope. So we're good to go. That should flip. So 70, 110, 190, 230, 310, 350, and then 360 is not a dot, it's just a boundary, okay? Got them all in there. Now tell me what you're going to test. I like to test 0 for trig, as long as there's not a dot there. Now, just because it's back there doesn't mean anything. That's just an invisible fence or whatever. So if I plug it in here, sine of 0 is 0 times 2 is 0 plus 1 is 1 is positive is false. So this is going to be false, true, false, true, false, true, false. Now these last ones actually go through the ends of those boundaries. Okay, so our final answer is going to be 70 to 110 parentheses union 190 to 230 parentheses. You got to put the degree symbol here because otherwise these are going to be interpreted as radians, which they are not. Okay, so there we go. That's your answer. That's the work I want to see. I need to see the test. I need to see your line check. Okay, this one getting a little more complicated. You got to use some factoring techniques here. Zero product property. Alarm bells going off. That's going to be one that bounces off the graph. So we got to keep track of those. When does cosine equal 0? 90 plus 180k. No reference angle, special case. When does cosine equal 1? At 0, which you need to include, plus 360k. Or, no, yeah, 360k. Okay, so x equals 90 and 270, and x equals 0 and 360, but these are the star ones, the ones that bounce off the graph. So then we do a line check. Now these are solid dots. There's 0, and then 90, 270, 360. Okay, these are the star ones. So when I test a value, now I can't test 0, so I'm going to try and test something else that's super convenient. I would say maybe 180 would be good. Now cosine's -1, so be careful. So it's be -1 times -1 is +1, minus -1 is another +1 is 2 is true. True, false, 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 false. Now I want to see that you caught these bounce issues, even though if you didn't, you would have got lucky and got them right probably, as long as you didn't test outside these boundaries. If you test outside these boundaries, it would have messed up your answer. Now 0 is an answer on its own. In fact, totally on its own in general, not just because of our domain issue. Bracket 90 degrees to 270, union, curly braces 360 degrees. These should be in order, left to right, like they appear on the number line. Okay, so that's your answer. Next one, we need to move everything to one side equal to 0 before you start factoring. Otherwise, factoring doesn't make sense because you got to use the 0 product property. So we're going to factor out a cosine 2x. We're going to have a cosine 2x left and a -1. Okay, so then we set this one equal to 0. And we set this one equal to 0. Alarm bells, alarm bells, alarm bells. This is equal to plus or minus 1. So that's going to be that bounce issue that we need to make sure we keep track of. When does cosine equal 0? This is very similar to the last problem, right? At 90 degrees plus 180k. When does cosine equal 1? At 0 plus 360k. Now this time these bounce ones are going to end up in the middle of our work. So you're not going to get so lucky as you did last time, but I'm taking off points anyways for luck. Okay, just be careful. Show your work on these. 0 plus 180k. So we're getting x equals 45, 135, 225, and 315. And then over here we're getting x equals 0, 180, and 360. And these are all that special case. So then we do a line check. These are all solid dots, 0, 45, 135, 180, 225, 315, 360. Okay, put the little brackets on there. Now we're going to test something. Now be careful, 180, 0, and 360. Put these stars next to just to keep track of them. All right, what do you want to test? I love test 0, but I can't. But remember, anything you plug in here is going to get doubled. So if we do, say, 90, it's going to be 180. So I'm going to do 90. X equals 90. And so then cosine of 180 is negative 1. Squared is positive 1 minus negative 1 is 2 is not less than 0 is false. So 90 is false. So that's where that starts. And then this is going to be true, 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 false, true, true. So at these stars, it's staying the same on both sides. Okay, so the final answer is 0 to 45 brackets. Union 135 to 225. Don't break that up. Those are all solid dots. There's no reason to break that up. Union 315 to 360 degrees. Okay? So that's it. That's your answer. That's the work. Okay? So next one, everything's on one side equals 0. Good. So we can start factoring. I think we got to factor out a cosine 3x. And then we have a 2 cosine squared 3x still left over inside minus 1. And then we use 0 product property. This equals 0. Over here, you got to watch out. Cosine squared 3x equals 1/2. But then we're going to take the square root of both sides, plus or minus. This is going to be plus or minus root 2 over 2. That's actually all 4 quadrants. So reference angle here is, when does cosine equal root 2 over 2? 45 degrees. But it's plus or minus. You got to do the plus or minus. It's quadrant 1, quadrant 2, quadrant 3, quadrant 4. It's all the quadrants. Now, when does cosine equal 0? At 90 degrees plus 180k, divide by 3, x equals 30 degrees plus 60 degrees k. Okay, now this one, when we could take advantage of something. 45 degrees is a special value that happens exactly, these are happening exactly 90 degrees away from the next one. So we could do one expression for all 4 quadrants of 45-degree angles. I don't know, that's a way to go. You don't have to. You could do all 4 of them. You'll get the same answers I get here. You do 45 plus 360k, 135 plus 360k, 225 plus 360k, 315 plus 360k, divide by 3, all over the place. It's a lot of work to get these same answers this is going to give me. Now, any bounce issues here? Nope. So we get 30, 90, 150, 210, 270, 330. This is going to have a lot. And then this one's 15, 45, 75, 105, 135, 165, 195, 225. 255, 285, 315, 345. Oh my gosh. Don't lose any of these. Okay. Because we're getting 4 answers times 3. There should be 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Okay, so I'm going to make a super long line check here, and I'm not even trying like put the boundaries on yet. I'm going to try and just put, I need to fit all these on. Now, these are all open dots. So 15, and then 30, and then 45 and 75. 45, 75, and then 90, and then 105, 135, 105, 135, and then 150, and then 165, 195, 65, 195, and then 210, and then 225, 255, and then 270, and then 285 and 315, and then 330, and then 345, and then finally 360 for the boundary. Don't miss any. All right, here we go. I'm going to test one thing. Test 0. Ooh, I get to use 0, my favorite. Cosine 0 is 1, so it's 2 minus 1 is 1, is not negative, is false. So this is false, true, 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 false. Darken them in. All right, wow. Okay, now we get to write our answer in interval notation. This is like the monster problem. 45, these are all parentheses. Got to write degrees. Otherwise, it's interpreted as radians. Hopefully I didn't make any mistakes. It's looking good, I think. That's an answer. All right. Next one, we got to move everything to one side, equal to 0 first. Otherwise, factoring does not make sense. And then this is kind of like a quadratic trinomial, right? So sine 2x, 2 sine 2x to get 2 sine 2x squared. 1 and 1. You need negative in the middle, so negative goes here, plus goes here, less than 0. So then sine 2x equals negative 1/2, and sine 2x equals 1. We're not doing any less than greater than stuff here. We're just trying to find the root. So this is alpha equals 30 degrees, quadrants 3 and 4. So 2x equals 180, 210 plus 360k. And 2x equals 330 plus 360k. And then, alarm bells, alarm bells. I got to keep track of that. 2x, when does sine equal 1? At 90 degrees plus 360k. Divide by 2, 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 divide by 2. X equals 105 plus 180k. X equals 165 plus 180k. X equals 45 plus 180k. All right, so then that's going to be 105, 285, and then 165 and 345. and then 45, and then 225. But these are the star ones, okay? So then we're gonna do our line check. 0. These are going to be all open dots in order. 45 has to go first, which is a star next to it. Then 105. Then 165. And then 225, which has a star next to it. And then 345. And then 360 just to cap it. Test. Ooh, I get to use 0. X equals 0. Tell me what you test. Sine 0 is 0. 0 is 0 less than 1. It is. It's true. True. Okay. True. This stays true because of the star. False. True. Stays true. False. So these are our answers here. Let's see. Did I make a mistake? I feel like I left something out. 45 to 25. Oh man. I feel like I'm missing something. I'm missing 285. Oh, 285. Gosh dang it. 285. So this is true. This goes to false. And then this is true. Just missed one. Okay, so final answer. We got to break it up because those are open dots. So we're going to say 0 degrees, but it's a bracket on 0 because we include 0 and it's not a place where there's an open dot. To 45, parenthesis, union parenthesis 45 to 105, union 165 to 225, union 225 to 285, union parenthesis 345 to 360, bracket on the 360, because those are on the edges and these go through those boundaries. All right, some good tedious trig for you. Are you ready for it? It's basic though. It's pretty, I think you guys have done much harder trig. Okay, let's look at these. So certain topics from this chapter are on each part, So like all the law signs, law cosine stuff, that's on the other section. So okay, now on this kind of problem, what I'd recommend is to say, okay, ABE is equilateral. ABE is equilateral. Okay, which means it's equal angular, which means this is 60, 60, 60. They tell you that ABC is 15. That's this angle, ABC. They tell you CD is 2. And they want you to find all this stuff. I try and find everything I could. If this is 15 and this is 60, then this has to be 45. That's 90. This has to be 45. You have 45, 90. So if this is 2, then this is 2, and this is 2 root 2, because your 45, 45, 90s. Right? Now, if this is 2, this is 2, and then you have a 30, 60, 90, right? Because this cuts that in half. You have 30, 60, 90. You have the short leg is 2, the long leg is 4, and the hypotenuse is double the short leg. The long leg is the short leg times root 3. So if that's 4, this is 4, and this is 4 right here. So I'm trying to find just all the missing stuff. I think if you do that, it makes everything easier. So I think we have everything. This right here is going to be 2 root 3 minus 2. So what's the perimeter of triangle ABE? That's the big one, right? With the equal sides, 4 plus 4 plus 4 equals 12. Okay, what's the perimeter of triangle ADE? ADE is this right triangle over here. That's going to be 2 plus 4 plus 2 root 3. So that's going to be 6 plus 2 root 3. no calculators, exact simplified answers. Perimeter triangle ABC, that's this one over here. That's going to be 4 plus 2 root 2 plus 2 root 3 minus 2. And so then that would be 6 plus 2 root 2 plus 2 root 3. That's the best you can do there. Area, oh yeah, that's perimeter, sorry. Area of triangle ABE, well, that's 1/2 base times height. ABE, the base is 4, the height is 2 root 3. So that's going to be 4 root 3. And then the area of triangle ABC is this one right here. That one's a little potentially more complicated. ABC. So, let's see. Can we use one of those? Okay, what we could do is we could say this is the base and then this is the height. That's what I would do. That'd be the easiest. So the base is 2 root 3 minus 2, and the height is 2. So the 1/2 and the 2 cancel, and we get 2 root 3 minus 2. That'd be the easier way. Yeah, another way is to use this as the base and draw the height in, and then now you got to start using like trig and stuff or other special right triangles, which would be more difficult. I would go with use the base and the height. Okay, so there you go. Just now, my best strategy there was to find every angle, every side, just whatever was most obvious as the next step to find. I didn't try and find them in a certain order. If you get stuck on this, trying to do these in order until you find everything, I think that's much more difficult. So, okay. Sketching trig graphs. So we've been doing these on homework. So you should have kind of a basic idea of what I expect, what I want to see, the kind of work I want to see, the way I want the answers. Indicate the max mins, indicate the period in radians and degrees. I'm gonna say that on test A. It's going to be in my solutions. I would like them in quadrants 1 and 4. I just want a period. So let's see. I'm going to start with this. X, Y. So let's see. Usually the period's 2 pi, 360. We're going to just graph parent graph first. Cut it in half, cut the halves in half. Amplitude of 1, -1. Cosine curve starts at 1, goes to 0, goes to -1, goes to 0, goes to 1. And we're going to make this a light dashed line, okay? Now, the pi on the inside divides the period by 2, so it's 2 radians, okay? Or 360 over pi degrees. The 3 makes the amplitude go up to 3. So that multiplies all the y values. And so that's what we get. And then the negative, which I guess you could have done with the 3, flips it upside down, multiplies all the y's by negative, which visually looks like it's being reflected across the x-axis. So that's our final answer. We're going to make that nice and solid and dashed. I want these dots very obvious. Your period needs to be labeled in radians and degrees. I want the max labeled here with a horizontal dashed line. So that's the answer I'm looking for there. So next one, let's see. X, mark period off, 2 pi, 360 degrees initially, cut it in half, cut the halves in half to get your quarters, -1 to 1, and arrows on the ends of your axis, label your axis. So we're going to start with the sine curves, 0, 1, 0, -1, 0, light dashed line. The 2 on the inside divides the period by 2, so we get pi radians and 180 degrees. Now the negative flips it. Now, I don't need to see the whole thing flip, but I want to see something. This gets over here, this gets over here, so it looks like this. It's a mirror image across y-axis. I want to continue it back into here. So we're going to continue it back into the positive quadrants. So this is our new graph. It effectively has the same look as flipping the graph upside down for sine. Then we're going to multiply by 3. You got to do reverse. You got to do order of operations. So it's the upside down version looking one. So you got to keep track of the last step. Y dash line. Plus 1 is going to move everything up 1. So we're going to go up to 4. So this is going to go up to negative 2. This is going to go up to 1. This is going to go up to 1. This is going to go up to 4. This is going to go up to 1. And so then this would be our final graph. Make it stand out, solid, dark. Okay, period has been labeled. It's one full period. I want the max emphasized and the min emphasized, negative 2 to 4. So that's what I'm looking for. Okay. Ooh, these ones have absolute values, which make them more fun for sure. So we'll just start with what we usually start with. Period, 2 pi, 360 degrees, amplitude of 1, negative 1 to 1. Cut it in half, cut the halves in half. So we'll start with the sine graph, 0, 1, 0, negative 1, 0, light dashed line. The 2, which is the next thing to do, multiplies the amplitude by 2. So, by the way, the period stayed 2 pi 360 this time. The minus 1 moves everything down 1 before the absolute values. Okay, order of operations. Do what's inside grouping symbols first. So that's going to move things down to here. So this is our new graph. Now, this is where things get interesting. The absolute value flips negative parts up. So this negative part goes up here. So we have this part and this part. This goes up here. This goes up to positive 3. This negative 1 goes up to positive 1. So this is what the graph looks like. Now I'm starting to make them solid just to try and keep track. I'm trying to avoid making it too dark. So that's our new graph. And then the minus 2 moves everything down to. So this moves back down to here. This moves back down to here. This moves back down to here. The 3 moves down to 1. This 1 moves down to here. And then these are going to be like right here. And so you have this portion of your graph, which is going to be dark and solid. And then this should be concave up, creating this very sharp fang kind of looking corner here. And then this is what we get. So that's absolute values usually create some really sharp corners. So our max is at 1 and our min is at negative 2. Okay, that's it. That's what I'm looking for. All right, next one. Next one's more fun in some other ways. It's good, challenging problems. All right, so 2 pi, 360 degrees, cut in half, cut the halves in half. Cosine curve starts at 1, 0, negative 1, 0, 1, light dashed line. Okay, now we need to factor the negative 1/2 out of everything, which gives you minus 2 pi over 3. Factoring is division. Division is multiplication by reciprocal. So if you divide negative 1/2 out, it's the same as multiplying by negative 2 over 1. So we need to divide the periods by 1/2, which gives you 720 degrees and 4 pi. The negative flips it across the x-axis, which, by the way, looks like it does nothing to a cosine curve. So that's taken care of. Then we got to move it 2 pi over 3 to the right. Okay, well, if this is 4 pi, then this is 2 pi. This is pi. This is 3 pi. Moving everything 2 pi over 3 to the right means it's going to be like right about here, 2 pi over 3. Right? So everything gets moved over 2/3 of one of these sections. So So this is now here. 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 And this is what our graph looks like. Now, I'm okay with you just starting a graph right here. I mean, you could try and bring it back here, but it gets a little potentially complicated. But I'm okay with the one period being. If the shift is weird, which this one is, if it's nice and it's like a nice increment of the graph and it works out really nice when you bring it back to here, then let's do that. But if it's weird, I'm fine with you saying, well, this is the period. Or you could go back here and still do it 0 to 4 pi. You could do it here to here or here to here. Okay, what else do we got to do? We got to do the +1 before we do the absolute value. So this is going to be up here. 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 And this is going to be up here. So that's the new graph. Okay, something like that. Okay. Oh, hold on. When I did the 2 times, I haven't done the 2 times. I've skipped the 2 times. So I skipped the 2 times. Oh man, I skipped the 2 times. So this is the new graph. And then we move it up 1. So this goes up to 3. This goes up to 1. This goes up to -1. This goes up to 1. This goes up to 3. So here's the new graph. I'm probably going to just make it not dashed anymore, just try and keep it straight. So that's that graph. Now we do the absolute value, which flips this negative part up, -1 up here. And so we get these really sharp folds. This is the final answer. Get this part's nice and smooth and goes perfectly into that next part of the curve, and then it forms that really sharp corner right there. So that's your curve. That's 1 period worth, by the way. Now you could either do that, or you could have brought it back over to here, but it's going to be something like this, and it's going to be kind of weird. It's going to get chopped off right here, and wherever it stops here is where it would pick up over here. So that could be your 1 period. But it's a little awkward this time. So I'm fine with you just doing that as your 1 period worth, starting at the shift if the shift doesn't work out super nice like it did this time. There you go. The period is 4 pi. The period is 720 degrees. We want to label the max, and the min is 0 this time. Okay. So just try your best on these. They get a little messy, so you got to be really just like, meticulous and step by step. So that's it. Pretest for the non-calculator part of the test.